So your 1, 2A homework were these problems, okay? So let's talk about 1 through 6. It says name the domain and range of each relation using interval notation. Okay, so I would like to pull out a few of the weirder ones, especially like 1 and 3 I'm looking at, are kind of funky, okay? So let's jump to number 1. Now, the way that you want to think about domain is as you walk across the graph from left to right, okay? And think about if it could somehow make a shadow, and every place it touches the x-axis is a good way to think about it. The range, you want to think about going from the bottom of the graph to the top of the graph, okay? So if we look at problem number 1, what you can also kind of think about, it's a silly way to think about it, but it's also helpful, is if you had a little math bug, if he started on the left of the graph and he walked to the right of the graph, what x values would he cover along the way, okay? So if our little math bug starts on the left of the graph, he can go really, this is going to keep expanding to the left, he can go out this way as far as he wants to the left and get started, okay? So he starts way, 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 way out here, and he's gotten to this point by now, okay? So he can use all the x's, he's all the x's, all the x's, all the x's, all the x's. So because of these arrows, he can eventually walk every x he wants to walk. So the domain for this one in interval notation is from negative infinity to positive infinity. He can walk as far left as he wants. There's no little problem areas that he has to leap over and skip an x. There wasn't a hole. There wasn't a gap in the graph. There was nothing to make him jump across some kind of barrier or obstruction. Now, the same math bug, his friend, is the range math bug. Now, the range math bug doesn't go from left to right. He goes from the bottom of the graph to the top of the graph. He can go down as far as he wants, okay? He's hitting along the way all of these. He has to go up a bump and down, but he can hit eventually this height and 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 this height. He can hit every height along the way. He has to take weird paths to get to some of them. But the range for that bug is also from negative infinity to positive infinity. So you have to think about the path that you're taking. Am I missing anything? Am I skipping anything? What y values or heights did I miss? He's not missing any of them, okay? Does number 1 make sense? Okay, let's look at a linear function like number 2. Now we're assuming it's off the graph paper, so let's assume that that's going to keep going on and on. A linear function like this, except for maybe a horizontal line, that type of linear function, you're stuck at one height the whole time. But for this one, think about the domain. That math bug that's going left to right eventually can start all the way at negative infinity if he wants. He can keep going forever and ever to positive infinity. The domain is all real numbers from negative infinity to positive infinity. His buddy, who's starting at the bottom of the graph and getting to the top of the graph, bottom to top, is also from negative infinity to positive infinity. Now, it's going left to right a little quicker than it's going up and down. He's going to have to walk far, far, far to get down to negative infinity and way, way far to get to positive infinity. But he still can get there. It's not a matter of what's showing on the graph. It's where could he get? Does that make sense, what you're looking for? Okay, so let's do 3 because there's distinct starting and stopping places, okay? So let's think about our little math bug for a minute. Let's talk about domain. What is the leftmost x value that he can start at?
-3. Wait. -5.
He can start at -5. Can he stand there? Is there a hole there? Is he allowed to stand there? Yes. So he can stand there. If he walks from that x value of -5, he's hitting every x value along the way, because his shadow would be down here. And what x value does he stop at? 5. So if you think about how he kind of goes along the x-axis, so we would write that the domain is from -5 to +5. That indicates that we skipped nothing in between, okay? Now, range is bottom to top. If the range bug is at the bottom of the graph, what height is he at? If the range bug is at the bottom of the graph, what height is he really at? He's at the y value, -6. Now, he can get to a height here that looks like maybe it's about 3. But if he's over here, wouldn't he get to 4 and 5 and all the way up there? So what's the highest this bug could ever get to?
Wait, +6?
Height. That doesn't make sense.
But you said what?
No. They just labeled it wrong. Let's assume that's +6. That definitely would not be the 0.5 -6. Let's assume that's 5, 6. So what would his height be? 6. Can he stand there? Yes. Now, if it had an open circle, you would put a parenthesis. Like number 4, you have to use some open circles there. Okay? 5, closed circles. 6, open circles. Okay? Now let's look at this number right here. Let's go to this one. Okay? It says use the graph of the function to estimate where f of -2.5 is, f of 1, and f of 7. Let's do the first one together. F of -2.5. Remember, this is just saying when x is -2.5, what is your height? So you're going to go over to -2.5. What does it look like our height is? What does it appear when x is at -2.5? We are at a height of?
12.
I think 12 too. So that's going to be 12. So that's how you would use the graph to find those things, okay? Do we have any questions about that homework? Okay, so what I'm going to do before we jump to the worksheet, I'm going to give you like 10 or 15 minutes to work on this homework, and then you can ask me questions, okay? So let's do that first, and then we'll go to the worksheet.